Find all values of theta in the range of theta between 0 and 360 degrees, satisfying 4 cos 2 theta equals 1 minus 2 sine theta. Express 8 sine theta x 8 sine x plus 15 cos x in the form r sine x plus alpha, where r and alpha are constants with r greater than 0 and alpha between 0 and 90 degrees. Find all the values of x in the range of x between 0 and 360, satisfying 8 sine x plus 15 cos x equals 11. Find the greatest possible value for k so that 8 sine x plus 15 cos x equals k has solutions. Give a reason for your answer. Okay, so let's have a look at this question then. I've got the summary of it here. So we need to solve this trig equation first in part A. So let's have a look at that then. So here we can use a double angle formula. We're solving between 0 and 360, of course. Cos is 2 cos squared minus 1, isn't it? So here we've got 4 lots of 2 cosine squared. Theta minus 1 is equal to, so I've replaced the cos 2 theta by this, is equal to 1 minus 2 sine theta. And straight away that's not correct because basically this is a sine on this side, so I need to replace cos by not this form of the formula, but 1 minus 2 sine squared, isn't it? And now we've got a quadratic in sine. Okay, let's expand the bracket. 4 minus 8 sine squared theta is 1 minus 2 sine theta. Let's move everything over to the right hand side. This becomes plus 8 sine squared theta. There's a minus 2 sine theta already there. Move the 4 over. 1 minus 4 is minus 3. It equals 0, but I'm going to write it down from right to left. Okay, so I've moved everything over. I moved the 8 minus 8 sine squared over, became plus. I had the minus 2 sine theta as is already there. And I moved the 4 over to minus 4. 1 minus 4 is minus 3. And then everything was moved over to the right, and I wrote it down from right to left. So it equaled 0. Now we can factorise. It's got to be 3 and 1, hasn't it? Now what would it be? 4 and 2? Yeah, it looks like 4 and 2, doesn't it? This would need to be 4 sine theta, and this would be 2 sine theta. We've got a minus 2, so that would be a minus. This would be a plus. So there's our guess. Let's just check it. 8 sine squared. Yeah. Minus 6 plus 4 is minus 2 sine theta, and then plus times a minus is a minus. 3 ones are 3. So that's the answer there then. So that tells us here sine theta is equal to minus 1/2, and here sine theta is equal to 3/4, isn't it? So let's solve these two trig equations then. Circle, right cast. We're solving between 0 and 360, and sine is negative in this first example. Sine is positive here and here, so it's negative there and there. So draw the two lines and mark off alpha, the associated acute angle. Right, sine alpha equals 1/2. We know that then alpha is 30 degrees, don't we? So theta then, the first solution will be round to here. 180 plus 30, 210 degrees. The next solution, right around to here, isn't it? 360 back 30 is 330 degrees. Now this one, again CAST. Sine is positive here and here, so draw our two lines. Mark off alpha, the associated acute angle, and write sine alpha equals 3/4. And then we can work out alpha. So it's going to be shift sine on our calculator 3/4, and we need to be in degrees mode. So shift sine, we're in degrees mode, shift sine of 3/4. Close the sine, shift sine bracket, inverse sine, 48.6, isn't it, degrees? 48.6 degrees to the nearest tenth of a degree. So theta is equal to then. Okay, 48.6, we'll go around to here, don't we? Here's the first solution, which is 48.6 degrees. And the other solution is right round here, which is round 180 back 48.6, which is 131.4 degrees. So there's our solution set then. Okay, that's part A done. Now let's move on to part B. So we've got to write this 8 sine plus 15 cos. So 8 sine x, wasn't it? Or theta. Let's have a quick look. 8 sine plus 15 cos x. 8 sine x plus 15 cosine x was equal to r sine x plus alpha. Okay, so the r sine is r sine, let's expand this compound angle, sine A cosine B plus r lots of cos A sine B. So that tells us then, equating sines and cosines. First of all, the sine x's, r cos is 8. And the other one, r sine alpha is the other coefficient. R sine alpha is equal to 15 lots, isn't it? 15. Label this 1, label this 2. So tan will be 1 divided by 2. And that will give this divided by that. The r's will cancel. Sine over cos is tan. And that's 15 over 8. So we can work out alpha. It's acute, so it's just shift tan. So shift tan then. Tan 15 over 8, wasn't it? 61.9 degrees. So there's alpha. And so r, and also let's just square this, and we get r squared, because it's sine squared plus cos squared, is equal to 8 squared plus 15 squared. So that will tell us what r is. So let's look at r. Let's get our calculator. So 8 squared plus 15 squared. 8 squared plus 15 squared equals. So that's under the ants now, and then we do square root ants, don't we? Which will be 17. So there's r, and there's alpha. Okay, so we found out r and alpha then. And so we've got that. And that was part 1. Find x such that x is between 0 and 360 degrees, satisfying this. So part 2 now. 8 sine x plus 15 cos x equals 11. Part 2. So here, this expression, which is 17 sine x plus alpha, which we've got 61.9 degrees at the moment, because we've rounded it. I'll put it in there for now, and that was equal to 11. So that implies then sine x plus 61.9 degrees is equal to 11 over 17. Now we're solving this. Let's have a look back at part 2. X is between 0 and 360. So let's solve this trig equation then between 0 and 360 and see what we get. CAST. Sine is positive here and here. Mark off, draw 2 lines and mark off alpha, the associated acute angle. And write sine alpha is equal to 11 over 17. So that tells us what alpha is. Shift sine 11 over 17. Shift sine 11 divided by 17. Shift sine, wasn't it? Let's just do that again. Shift sine. There we go. 40.3 degrees. 40.32. Let's do it to 2 dp. 40.32 degrees. There's alpha. So now we can read off x. But it's not x in this case, is it? The angle in question is this thing here. So x plus 61.9 degrees is equal to the first solution round to here, 40.32 And the other solution will be around to here, which is 180 back 40.32, which is 139.68, isn't it? Okay, so that tells us what x is then. Is equal to, well, it will be 40.32 minus 61.9, but that's negative, and we're outside our range, so we need to do one full turn, don't we? And similarly, so we better put it in here as well, now that we know that. And also we got 139.68 minus 61.9, and that's in our range, no problem. So we added 360 because this was a negative angle, and we're looking for solutions for x between 0 and 360, aren't we? So we had a negative angle, so if we add one full turn, we'll get to the corresponding angle in the correct range. And when we added 360 there, we went back to our original problem and we thought, oh, we'll put in 360 there when we write the actual solution at the outset. So that tells us then 40 minus 61.9 then, 40.32 which we've got, minus 61.9, plus 360, and it's 61.9, plus 360 equals 338.42, 338.4, 4 degrees, or x is equal to 139 minus 61.9. 139.68 minus the 61.9. And we get 77.78, so it's 77.8 degrees. So there's our two solutions then for x in part 2. So to find the greatest k such that that equals k, 8 sine x plus 15 cos x, part 3. Part 3 then. So here for part 3, it's this 17 sine x. This equals k. So what was the question? That's what we've got as a problem. The question said, find the greatest k such that this has solutions and give reasons. Clearly then, implies k is equal to 17. And that's the max. Since, I'm going to write it here, sine is max, or has a max value, has a max value rather, has a maximum value of 1. So 17 times sine will be maximum when sine is maximum, which is 1. 17 times 1 is 17.